Hopefully the recording is going on. All right, so uh, you guys want me to see any? You guys want me to show anything on the bright space, or you guys are able to figure it out everything from there? You guys are able to figure out everything from there, right? So don't waste the time out there. Okay, so let's just go by agenda, I guess. So this is. All right, so let me quickly show you those equations that we learned in last class. First of all, just 1-2 minutes review. Okay, in last class we did learn about this normal and tangential component. We did talk about it where it could be applicable anytime you have a curved axis and you have the centrifugal and centripetal forces. Those two components are going to come. Force means acceleration multiplied with the mass, so acceleration will going to come. Two components of that acceleration, normal and tangential. Okay, a and t, at and an. So we have a few equations for that. I'm just trying to go there, so directly point out those equations. Okay, so this an is v square over rho, so that's one of the equation, and at can be found by dv dt. Okay, let's see if I have the equation somewhere. So at is that. Okay, so at or tangential component is dv over dt. A and normal is v square over rho, right? And this rho does have another equation, so this is the equation. So rho equal, on the numerator we have dy dx square. Okay, in the exam you might have to solve it to find it. In today's class we won't be solving that. Maybe at some point I'll be doing that. In homework you have to deal with that as well. So t square y. In next class maybe I'm gonna give you some hints on homework number 3 and homework 4. I gotta put it shortly. And you see, you guys remember the modulus sign? How many of you remember the modulus sign? What does modulus means? Is the absolute value, right? So means like it should be positive. Okay, the denominator value must needs to be positive. Everybody understand that? It was good. Modulus means, you're good, right? You're good, right? Modulus means positive. That's so important. Okay, I'm just trying to make sure everybody's with me. So okay, so basically to find the rho, again, what is the rho? Is it the density? No, it is what? Say like you're driving a car, right, which is following a curve like this way, and then you are interested to find the rho at every point. So if this is following an arc, a different point could have different rho value. Make sense? So what is this rho again? What do they call the rho? Anyone? Is it radius of curvature? Okay. It's radius of curvature. All right, so again the rho equation, I just wrote it one time. From this equation you gotta find, to explore this equation, you gotta find these two things, dy over dx and second derivative of y with respect to x. Okay, the first derivative and second derivative, you gotta find those, right? Can you do that? When, like, you like to give me you'd like to give me examples. So like y is a function of x, where you have 5. I'm just giving you a hypothetical scenario, plus 3x. Can you solve it? Can you see by from this equation, can you find the rho value? Do this. This is a quiz. I'm not going to grade it, don't worry. Okay, so do this. Find the rho value, and where it is important, because in homework you need to find this row. And did you see on the sketch I have row 1, row 2, and row 3? Why? Because it's not a circular motion. You could have a motion like zigzag, right? So you'll have row different every time it's going like different path, right? Does it make sense? Because every time it goes different path, you're gonna have a different dy over dx, and second derivative of y with respect to x, right? So those two things you're gonna find first. If you are given with the equation of y, where you can clearly see y equal 5x cubed plus 3x, it's arbitrary equation that I gave you, right? That equation could represent, do you understand, right? That equation could represent the curve, right? All right. So can you solve it? You're going to solve the differential equation, right? You're going to solve the derivative in this case. We did some practice, right, on the derivative. Everybody have to do some work, okay? Please don't do nothing. So you remember, right? So you have like say y equal to x to the power n. You got to know this equation. dy over dx is what? N x to the power n plus, sorry, n minus 1. I know what I was thinking. You guys remember that equation? So you got to use that one. And now you have this y equal two things, right? So you got to do the derivative twice. You know that, right? So in other words, you got to do, I'm going to walk around and I'm going to see if you understand or not, okay? So please try to proceed. Don't just wait for me to finish it. In that way, you are not engaging yourself, okay? So basically, if you have two terms, so what you got to do? Everybody know that, right? You got to separate it. This 3 looks really weird. Let me rewrite it. Plus this 3. You can take out the 3, but I'm not doing it now. Just writing as it is. Okay? Then you can solve it, right? So I'm going to work it out. And if you have a row value, just let me know so I can share it. I mean, this is a problem, I just made it up. So it's not like I can answer. So the row value I found 30. Okay. Is it 30x? Anybody else got 30x? 30x? Okay, so 30x is the answer for sure. If 2% get the same result, that is definitely the answer. I'm gonna do it, don't worry, myself as well. But 30x is the answer. That means if you have a good grasp on this row equation and grasp on this a, t, a, b, and a equation, then you're good for today's class. Okay, that's all it matters. Take a few more minutes. Okay, it shouldn't take that much of your time. Only thing you're focusing here, what, Joe? Trying to find the two derivative. Okay. So if you know how to deal with those two derivatives, the rest is not an issue because you know the equation. You just have to plug those values on the equation, okay? You got 30x as well? You got 30x? Perfect. We got it. One more minute, okay? Try your best to finish it. I have some very simple math. 3 maths all follows those equations. As long as you can use those equations, you simply manipulate them and then we're gonna get some answers out of it. Anyway, so I guess that 1 minute passed, right? Everybody got 30x. I know like 1, 2, 3, 4, 5 got 30x. Others were working on that. I don't know what's the progress, but hopefully you're gonna get it like if you have more time. So it doesn't matter. Let me solve it anyway. So for the first one, obviously you have this 5 will gonna come out, and then you'll have this x cube inside. 3 will gonna come out. You're gonna have this x inside, right? And then if you're gonna do those math, you're gonna have 3x 3 minus 1, and you might be wondering why I'm doing the same thing again and again. Just so silly sounds like, but it could be helpful to some students. Okay, so 15x square and 3. Okay, x to the power 0 is 1. Is that what you guys find for the first one? Okay, for the second one, you do have this answer for the first one already. So you have this 15 x squared plus 3, right? I don't know, maybe you were wondering why I'm writing it. I know it may confuse some students. So d second derivative of x with respect to y, second is derivative of y with respect to x. I'm extremely sorry what I'm saying. So it can be written as dy by dx. You know that, right? From differential equation, right? Arlen, you good? It can be written differential equation. You took differential equation. You're taking calculus. It doesn't need to solve differential equation. Calc 2. Yeah, you should be learning this derivative now over there at some point, if not now. What about you, Delino? You learned it before, Calc 2? You're done with Calc 2? You're learning it now? It could be a little difficult for two of you, right? Joe, you did Calc 2? So it should be a piece of cake for you, right? Sorry, I mean, not that much you can do about it, but and I'm trying my best to be a little bit elaborative. Okay, so you see, this one is this answer, right? You see the highlights. So what I'm trying to do here is like, another highlight is I hope you follows like what I'm doing here. So now obviously you got to do it like 15x square plus d by dx 3, right? And then this one would be obviously 0. So you'll have 15 here, and you wanna do x square derivative, so which will be what, like 2x? Is that the 30x everybody found? Is that the 30x? Okay, so then the row, what is the equation for the row? It's a little complex. It has like 1 plus dy by dx square 3 by 2 d square y dx square modulus, and then you're going to plug all the values. So you'll have this dy by dx is 15x square plus 3. It's not a simple math. I mean, you guys are so fast. How did you finish all of it? All right, it's square, right? 3 by 2. And then what? You have this 30x here at the bottom, right? Assuming x is positive, right? So x is positive. So, okay. And then what? You got to do some math here. So how did you do it? Use the calculator to do that or manually? Calculator? Everybody use the calculator? Brett, you use the calculator as well? Okay. So I believe the calculator is going to give you the right result. But if you want to do it manually, then it should be having something like that, right? 2 multiplied 15x multiplied 3. I won't be solving it though. Seems like it's too much work manually. Okay, so the whole thing should be 3 over 2. Okay, it is actually too much work. So you will solve this thing, and what is the value that you guys found? What is the value? You guys solved the row, right?
Yeah, I got 112.5 x to the fifth.
You use the calculator?
Yeah.
Because it's 3 over 2, right? It could be a little complex. Now, easiest way to solve this row value, which would be most of the case for your case, x value would be given to you. Okay, so what would be doing here? Just plugging the x value and get the value of row in numeric digit. Okay, but what is the value found? 100 and Logan?
112.5.
X to the power fifth?
Yeah, or x to the fifth.
Like this?
Yeah, that's what I got.
Anybody else get anything? You just have to put this thing on the calculator, okay? Or in MATLAB, symbolic math. MATLAB can do that as well. Nowadays, ChatGPT can do that, symbolic math, but don't use the ChatGPT. But MATLAB or Octave, you guys learn those things. You can do the symbolic math easily. Anyway, there's this function called solve. You have to use. I mean, if you're done with that Octave or MATLAB, solve is going to do it for you. There are other softwares in MathWorks. I don't know if you heard about it. MathWorks can do that as well. When we were grad students, we used to use the MathWorks to deal with this kind of thing all the time. Okay, some calculator can do that symbolic math, like yours one, Logan. Yours one, you did it in the calculator, right?
I just checked using the calculator, but I did it by hand.
You solved this thing by hand, the top thing.
Yeah.
Okay. Perfect. So anything else? So let me put an underline here because this needs to be verified. Okay. because I don't have it in the notes, so I gotta do it myself to verify. So anyway, any question here? If not, then we are actually ready for our math today. So there are like 3 maths, right? I have about 30 minutes left. Let's go one by one. No, not this one. Let me read through the problem and let's see if you. So see, you don't have to wait for me if you really have a good understanding on the problem, right, Joe? So if you have a good understanding of the problem, when I'm going to explain it, you can start solving it by yourself. Okay. So what this problem is asking you here. A car moves along a circular track of radius 250 feet such that its speed for a short period of time is 0 to 4 seconds. The velocity equation is given. Okay, the car is moving, bottom line, with the velocity equation is given. Velocity is a function of t is the time, right? And they said like it just only valid for 0 to 4 seconds. Got it? The car is moving, the velocity equation is given. So far, that's it. Then it says determine the magnitude of its acceleration when equal to 3. Okay, how far it travel in equal to 3 seconds. Now here's 2 things given. First, they say car is traveling around a circular path. Understand? As if like you have a circle track in a racetrack, whatever, and car is traveling. What's the radius of the circle? They gave you 250. What is that 250 again? It is the radius of the curvature. Same thing that you just found, rho. You just found the rho, right? Rho is the Greek letter, radius of curvature, right? And you found it, right? So that rho value is given. That's the first thing. Okay. What else is given? The velocity equation, right? So the velocity equation is given. The rho value is given. They give you the time t 3 seconds. Okay. What they're asking? Find the acceleration. So the velocity is given. Finding the acceleration. And is a curvature, right, which has both normal and tangential component, right? Immediately it comes to your mind, you're gonna find the AT and AN. N refers to normal component, T refers to tangential component. You guys remember I did show you that equation at the beginning of the class, right? In last class, remember that, in last class we've seen that as well, right? So those equations. So you're gonna use those 2 equations, AN and AT. Once you have those values, then you're gonna do what? Like A equal square root of AN square plus AT square. In other words, it's a Pythagorean that we're using for normal and tangential component of the expression. Is it clear to everyone? You can do it? By using those 2 equations? Try, right? Yes. AN, find the AN and AT first. Okay, you know the equations, right? For AN, which is AN is what? V square over rho, right? So do you have the V given? Yes. So can you do the V square over rho? Now you have V has all the T thing, right? You can plug the T value is 3 seconds. At that point, they're asking you the acceleration, right? So V square shouldn't be an issue, right? Finding that, just plug the value of the T is 3, right? Get me? So once you have the AN, what else you gonna do? Find the AT. What is AT again? AT is, isn't it like dV over dt? Remember that equation? I mean, they write it this way, V dot, but that's the same thing. Anytime dot means with respect to time t, right? You want to do a derivative with respect to time t. Joey, remember that? So can you find the AT as well? Means you gotta do a derivative on that equation, right? So you have the V given, you gotta do dV over dt, right? The V given, right? With the t equation. So you're going to do dV over dt, right? A derivative of the v with respect to time t. So once you have AT and you have AN, I mean you got it like the AN thing, right? Which is v square over rho, right? The v is given here. You see the equation? Here t is 3. You can easily find the v, right? Or v square. And the rho is 250, right? You can find the AN, right? AN is the normal component of the acceleration. You find the AT as well, which will be dV over dt. You have to do the derivative just one time. And you see you have like these 2 terms. You can do the derivative now, right? So many days, every day you are doing the same thing, right? I can give you the final answer. I know there are some advanced students, they can easily finish it because probably they are done with the calc 2 already. So the final answer for A should be 21.6 feet per second square. Okay, and your AT is 21, your AN is 5.18. Okay, let me give you the answer. So AN is 5.18 feet per second square. AT is 21 feet per second square. Okay, and A is 21.6 feet per second square. And it's not all. They also ask you to find how far it is travel. You understand? That means they're asking you to find the del S, and that del S value is 40.5 feet. Okay, once you're done a little bit, then I'll start solving it as well. Let me start with those, like, whatever the initial thing is, right? Like the givens. So givens, I'm highlighting it here. So they gave you the rho value, right? The radius. So they gave you the radius, which is 250 feet, and they gave you the V equation, right? The velocity equation, which is 3t plus t square feet per second, right? And they said, like, okay, it goes with a range for t value 0 to 4 seconds. And they're asking, find what they're asking at time t equal to 3 seconds. Two things they're asking you to find. The first thing is, what is the acceleration? Second thing is how far it goes, del S. So by looking into this equation, it could like travel like this, right? I don't know. I mean, anything is possible. Let me try. So like this is your path of travel, right? And so like a car that is moving, okay, from here. Okay, so they are asking, what is the del S? The path that it traveled, right? So they're asking that. Not only that, they were asking, what is the acceleration, right? So to find that, I know some of you already probably solved it, whatever I'm doing. You can just match it with mine. Your A, or total acceleration, is an square divided plus at square, normal and tangential component. So you can write it like, okay, normal component of acceleration an has the equation of v square over rho, and the v is given as with this, and rho is given as 250 feet, right? And this is what, like feet per second, right? And this is at time t equal to 3 seconds, right? Note, don't take it like it's part of equation. So then you're gonna simply just plug the values, right? Which you're gonna find. Christian, you are done with the A? Seems like. Can you find the del S as well? To find the del S, you wanna try this. So ds over dt, right? Equal v. You remember that? So you wanna rearrange things like ds and then v dt. You gotta do integration.
Yeah.
Okay, and then plug the v and.
So integral 0 to 3, right?
Yeah, integral definitely is 0 to 3, t equal to 3 seconds. Yep, so you have this S0 and S here. So basically, those who are advanced, like for them, I'm showing so you guys don't stop like waiting for me. So you have this S minus S0, which is equal to del S, right? And then you have this 0 to 3, you have this 3t plus 3t square, this integral that you got to solve, right? That those who are advanced, like you should be able to, and you find the del S value already? Okay, so then just chill for a while. Let me finish that. And there are other two problems like we're going to start. I don't know if you can finish all. You are done already also? You done, Brett? Also the integration? You understand the integration, what I'm doing? Why? Yeah, it's just like simply the v equation I wrote and then rearrange and do the integration both sides for 0 to t means like 3 seconds, right? Everybody got it? Okay, and left side is obviously del s. Anyway, so I mean, let me go with my usual pace, and this thing is just note for those who are in a little bit advanced stage. So basically what you're going to do here, just simply plug the value. So you have this 3 plus 3 square 250 feet divided by second. If you do the math, you're going to come up with a value of 3.18 feet per second square. How many of you got the value that I got? You got the same thing? All right, then the next thing would be, you get a different thing. Go back up like here. Like here. Okay. All right, so then tangential component. Let me write that. Tangential component of the acceleration. I don't know why I didn't put a the. Yeah, there should be a the acceleration. This is the acceleration that we are dealing with, right? Which would be what? Like this v dot, which is dv over dt, right? You don't know that, right? So obviously you gotta do the derivative, and then you have this 3t plus 3t square. I hope you understand. I'm just writing this multiplication of 3 for both times, right? Instead of writing that. Okay, let me know if you have issue with understanding that. So you have this 3. Okay, let me do that a little bit more about 3 t square dt. Okay, and then you have this 3 here, 3 multiplied 2t. So you're gonna have what? 3 plus 3 multiplied 2 multiplied 3 at time t equal to 3 seconds, right? This is note. And then you will have this at value. I do have it somewhere, I guess. 21 feet per second square, right? And then you have this acceleration. You can say this is equation number 1. From equation 1, I can write a equal a n square plus a t square, and then simply plug the value. 5.18 square, 21 square. I'm going to do the square root. I'll have a value of 21.6 feet per second square. Okay, up to this, how many of you got it? All of you? Okay. So the final thing, obviously, the del S, right? I was giving the hints, but I'm going to do it formally now. Any question on this? Delino, you good? Okay. So the part B. Okay, part B is del S that we are trying to find. Now, this is the thing that we did all the time. ds over dt equal to v. You guys remember that change of distance with time is the velocity, right? And then we're gonna rearrange things, right? So I have this ds equal v dt, and I'm gonna do the integral in both sides, s0 over s, t equal to 0 to t equal to 3 seconds. And then I can rewrite that as like, s minus s0, which would be del s, same thing. And left side, I'm gonna have this 0 to t equal to 3 seconds, right? And then I have this 3t plus 3t square dt. And then I have this 3t square divided by 2, 3t cube divided by 3, 0 to 3. If I'm gonna plug the value, I'm gonna have the del s become plug the value of 3. So I'll have like this 3 multiplied 3 square divided by 2, 3 cube, okay, minus 0, minus 0. Okay, it is in feet, so I'm gonna have 40.5 feet. So that's my answer, final answer. I think I have time to do another math, okay? Not two, but the interesting part would be the other two maths are very straightforward, similar to what we just did, okay? And some of your homework problems are same. So I'd encourage you to start solving the homework problem, okay? Homework number 3. So by Friday, I can actually put a new one because I'm planning to do a different topic on Friday, relative motion. So there is this homework number 4, relative motion. I can focus on that, okay? You can keep up with the work. In person if you have issues. If you guys are good, I'd like to proceed. Okay. I'm sorry, I didn't quite ask you. Does everybody finish writing this? By the way, all the lectures are in record, okay? I keep posting the lecture after every class. So if you have any issue with anything, go back to the lecture for the questions or whatever is missing. In case if you have something you'd like to see it again. And that's the other thing that I have for you guys. So I have two problems, right? There's these two problems that you are seeing, kind of very similar to each other, right? Let's read to the first one. You see, a car is traveling with a radius of curvature given. It's like car doesn't really, Joe, you understand? Car doesn't really have to travel a circular path. It oftentimes travel what? Like in a curve, right? So you can think you can focus only on the curve, only on this portion, right? So see, on that portion, they're saying, Joe, you're good with the new problem? Okay, so on that portion, they're saying, you see the rho value is 50. Rho is again what? The radius of curvature. All right. So then they said like, okay, the car travels along the road with the speed of v equal to second. So this s is not second, I'm sorry. This s is the distance that they were referring, okay? Where s is in meter. Okay, they give you the equation for the v. They're asking, find the magnitude of the car's acceleration at s equal to 10. So previous problem, if you recall, what did they give you? They gave you the v, where the v is a function of t. Do you guys recall that? So that was the equation previously. And over there they said at time t equal to 3 seconds, find the acceleration, right? Here what they're saying. So they gave you the v equation where the v is 2s. This is even more easier. And then they're saying find at s equal to 10 meter the acceleration. Can you do that? It should be super easy, right? Super duper easy. Why? Because you got to find the an, you got to find the at. An is v square over rho, at is dv over dt, right? And once you have those, you find the value of the a, which is an square plus at square. Okay, I want you to deal with that by yourself, okay? And I have the answer. As long as you can show me that you are done with that and give me the answer of a is 40.8 meter per second square, you guys are good. Now, it is, even though it sounds like so straightforward, it is not that much straightforward to find the AT. AN is that. AN is easy, straightforward. You guys are right on that, but AT, is the AT is that straightforward? So let's try. So on the AT, you have this V equal to S, right? Now, can you do the derivative of 2S with respect to time t when you don't know the S equation? Can you do that? No way, right? Do you know the relationship with S and T? It's not given. Do you know the relationship with S and T? No. No way. Because what? Try to take a look. When you try to find the AT, you know it's dv over dt, right? You know v is given as what, like 2s? You plug 2s, and you are stuck here. There's no way you can solve it, right? Right, Delena? S and D, is there any relation? No. So how do you solve it? So there's the thing. As I was saying, like it is not that straightforward, right? Even it sounds like so much. So you gotta do it this like ds over. Let me show it to you. Okay. You gotta do it this way. So you gotta do dv over ds multiplied ds over dt. You guys agree with me on that? So this ds and ds are gonna cancel out, right? No? Yes? Okay, perfect. All right, then, I mean, I'm just showing it to cancel out just for understanding only. So I'm rewriting it again, obviously, right? You understand that? So I have ds and dt. And then, can I do like this ds dt as like it is b? Can I write that? Change of, that's the equation for v, right? Anyway, at the first place. So can I write this as like v dv over dt again? I know I could have avoid all these steps and write it in one line, but sometimes it could be helpful to students. From experience, I know that. All right, so then obviously you have this the same thing that I'm doing. I could have write this thing next to each other at the bottom, right? Just to save the space here on the side. I'm doing it. Let me know if it confuses you. So what is the b they gave you? Is to I'm sorry, I did one mistake. It should be, you didn't stop me, right? It should be ds, right? Everybody? Now it's good? All right, so then can I do this derivative now? I'm doing the derivative of what? 2s with respect to s. Can I do that now? Is that good on the derivative? Everyone? Did you understand? Joe, you got it? Arlene, did you know? You got this thing? This is from calculus, okay? Think this way. You gotta focus here. AT is dv over dt. You know that, Arlene, right? Okay, here's the problem. You see the v doesn't have any t, so you can't solve it, right? So you gotta find this dv with respect to ds somehow, right? The way you can do it, straightforward. If you can put the ds at the bottom here, ds at the top here, numerator and denominator cancel out, it is become the same thing as dv dt, right? So now you have these two terms, one of these, another of these, right? Now you know this ds over dt is v, right? This is the velocity equation. You know that, right? So that's what I did. I just plug its v. What do I left off? dv over ds, right? So this dv over ds, I know this v is actually 2s, right? Do I know that? It's given. It's not like, I know it from other places. It's given, right? Right, do you know? So then, can I do this derivative? It should be straight for 2 should be coming out. And then v should be 1 when you do the derivative, right? And yeah, you got to do a lot of writing, okay? More the writing you do, more you're going to understand. So basically, all I'm saying, this will going to give you, so this, what is the v value they gave you? 2s. So I'm writing 2s. And I have 2 multiplied 1, right? From the next one. So I'm going to plug the value, you know what, let me put it as equation number 1, I guess. This one is v square is what, like 2s squared divided by rho. That's equation number 2. That's equation number 3. Okay, since I wrote all this thing on the side, I'm gonna do it one by one. So from equation number 1, can I write this thing as AT equal, I know my son keep calling me. All right, so AT equal what? 2s multiplied 2, which is 4s, right? And then 4 multiplied what, guys? What is the value of s given? 10 meters is 40 meter. Okay, meter per second square. That's what I should be writing. Okay, and remember, before I was talking with someone, Joe was talking other day or somebody. I was explaining the thing is like, even if you are getting like plugging the value of the s in meter, but why you are getting like meter per second square? Because of the constant that you have has a unit in this case. Okay, You understand? Oh, the Gavin was probably asking someone. I forgot now. All right. So an should be what, guys? Again, you have this 2s square divided by rho. 2 multiplied 10 square divided by rho means you have this 20 square means 400 divided by rho is what? 50. So that one we're gonna give you meter per second square. What's the value? 4, right? 8. Sorry, it should be 8. So then you have the final answer is what? The an square 80 square 80 square plus what? 40 square. You're gonna have 40.8 meter per second square. That's your final answer. All right. Okay, that's it. I guess. 1 second. I'm worried.
Is 25 times 2, what does that say? Is that 2.5 or 25?
Huh?
2s.
That's
Oh,
the 2s. I'm sorry.
Yeah.
That is 2s. So 2 multiplied 10. Okay. Sorry. All right. To give you an overview, what we learned today, we learned to find the acceleration value A. We learned to find how to find the distance del S. Right. So for del S, we did the integration that we understand from ds over dt equation, right? The equal. But for A, it has two parts, AT and AN. Okay, tangential and normal component. For AN, we know the equation is d square over rho. The rho does have another equation. We did learn on that equation as well, right? But AN and AT. But AT is like kind of straightforward. It is dV over dt. Okay. Now, depending on the value of v given in either in terms of t as a function of t or in terms of s, things can be a little bit different. Okay, as you've seen in two different problems. Okay, so those should be a good start point to start solving the homework number 3. Homework number 3 then? Yeah, homework number 3 is already up, right?
Yeah.
So those should be a good start point to solve homework number 3. And on Friday, our agenda should be talk a little bit with homework number 3, upload the homework number 4 on the same day, start a new topic, and finish the last problem here. Start a new topic is called relative velocity. Okay, and that will be the last topic, most likely in chapter 12. And then there's the chapter 13 we're going to start up. Okay, not that in chapters is going to take dynamics, just to give you a heads up. Okay. I'll see you again on Friday. Okay.
Yep.
My son.